In this video, I'll be sharing how I modeled welds on the frame in preparation for structural analysis whilst working at Triumph. So the first thing I like to draw your attention to is the shape of the weld. See, they're actually more convex than concave. And whilst there's variation throughout the weld, we should always consider the worst case for packaging. Now the first thing I'm going to do is I'm going to create a new part for each weld. The reason for this is that we need the components and the welds to be treated as separate entities. Now the modeling itself is not so difficult, but it does require a bit more than just adding a round or chamfer. Now in Creo, when we create an offset surface from external geometry, we could then convert that to independent geometry. In Fusion360, we can do that by using the convert to DM feature. So there's a couple of reasons why we do this. Firstly, if we change the geometry of the part that it's referencing, that can then have a knock-on effect and maybe cause some features to fail in this part. And secondly, when it comes to checking our parts into the PDM system, if there are external references, parts linked together when they shouldn't be, it can cause problems with trying to check those in. Now I'm actually not following best practices here, and I haven't converted these surfaces to DM features. But I'm not really worried in this case because this is just an example assembly. So I'm just going to explain quickly how I choose the offsets for the surfaces. I'm going to refer to these tubes as vertical and horizontal tubes. Because we're welding onto a rounded surface, we don't need a large offset from the vertical tube to make our intersection with the horizontal tube. For the vertical tube, however, we will need to offset the horizontal tube a bit more. If you notice on the Kawasaki frame pictured earlier, the welds go from say 5 to 10 millimeters. Since the weld penetrates the surface of the material, and also fills gaps, I'll be building the weld to be filling the small gap between the two tubes. So I'll be extending the internal surface of the vertical tube to intersect with the horizontal tube, and that's going to give us the internal surface of the weld. We'll need to trim the material that's extended into the tube. Now we can do a similar approach using the vertical tube's offset surface, extending that into the horizontal to get the outer perimeter of the weld. When you have surfaces like this, we got two options. We can select them and just click delete, or we can actually use the remove feature. Now I need to get the high point of the weld, so that's going to require an offset of the horizontal tube to intersect with the external surface of the vertical tube. So whilst I'm making a mess of this, I'd just like to explain a couple of points about these models. So these are just being used for this example. If these were going to be real tubes, there would be a number of extra details that you would see here. And perhaps I'll include that on another video before we go more into depth on the actual frame design. But the kind of details you could expect would be those required to produce the tubes, manufacture the tubes, those to secure the tubes in a fixture, to control the tolerances, to provide drainage, and other details that have to ensure that we get good weld quality. Once I have these set of surfaces, I'll stitch them together to have a single quilt. I'm going to be sweeping a surface around this weld, and in order to do that I want to have a strong point, so I'm using the plane to split the surface here, and then I'm going to draw a sketch on that plane using that point that we've just created. Now I'm going to use the 3-point arc to create the profile of the weld. Now when sweeping the surface, I'm going to change it from single path to path with guide rail. I'm going to keep the top surface as the path and the guide rail as the lower surface. And that finishes the shape of our weld. Now I just need to stitch it together to create the solid part. Now if you have stuck around to the end, I do really appreciate it. It's good to know that there are people out there that are interested in what I have to share. So what can you expect next? Well, I'll be modeling a tubular frame using these welding techniques to join it together. I'll also be doing some sheet metal brackets or pressings to strengthen the frame. And from there I'll also include the pillion hangers, which I modeled in a previous video. And that sets us up to be ready to run some static analysis with pillion loads working through the frame. And with that, I'd just like to say thank you again to everyone that stuck around to the end.